Good morning to all. Myself Dr. K. Manoharan, Associate Professor, Department of Biomedical Engineering. So today class we are going to see about 8086 addressing modes. So addressing modes, how the data will be accessed for that particular instruction. So that will be addressed here. Look at this. So every instruction of a program has an operand to operate the data. So the different way in which the source operand is denoted or accessed, so this will be known as addressing modes. Look at this different addressing modes that supports 8086 microprocessor. So first one, register addressing mode. Second one, immediate addressing mode, direct addressing mode, register indirect addressing mode, base addressing mode, indexed addressing mode, base index addressing mode, string addressing mode, direct IO port addressing modes, indirect IO port addressing mode, relative addressing mode, and implied addressing modes. So these are the addressing mode that supports 8086 microprocessor. We can group this. Look at this group 1. This is addressing mode for register and immediate data. This is group 1. Look at this group 2. So this is the addressing mode for the memory data. So the way of data accessing to the memory directly, indirectly or indexed. So this will becomes this group 2. And third one, addressing modes for IO ports. So direct IO port and indirect IO port addressing. And group 4, this is relative addressing mode. Group 5, this is implied addressing modes. So in this group 1, so the register addressing mode and immediate addressing modes. So register means that both source and destination must be a register. Immediate means the instruction itself, it contains the values. So here the address will be mentioned. So from that address the data will be accessed. So if you take a group 2, this is then addressing modes for a memory data. These memory data can be mentioned in different ways. So here look at this direct addressing modes. The address is directly mentioned. Register indirect addressing modes means the address is indirectly mentioned in the register. So base addressing modes, the base pointer will be used as this offset. And index addressing modes, that SA and DA index register will be used for an offset register. Base index register. So both base register and index register will be used in this base index addressing mode. And then string addressing modes, like and directly performing string operation, we use this string addressing modes. So for an IO port, we can mention it directly or indirectly. That will be comes under the group 3. That is the addressing modes for IO ports. So the address mentioned directly means it is a direct IO port addressing. If the address is mentioned indirectly using register means it is called indirect IO port addressing. And then group 4, this is relative addressing modes. So that means that particular location from this to whether it's a plus or minus that particular. So these will be relative addressing mode. And last one, implied addressing modes. That means the address or a data that will be present in instruction itself. This is called implied addressing mode. We can see each one detailedly. Look at this first one, register addressing mode. So the instruction will specify the name of the register which holds the data to be operated by the instruction. Here the both source and destination must be a register, and then both source and destination must be a same size. Look at this example, move CL, DH. So CL is a destination register and DH is a source register. The data present in DH register will be moved to destination, that is CL register. So both source and destination must be a register. Look at this, both will be have a same size also. Look at this another example. So we can take another example like this, move AX, BX. The content present in BX register will be moved to AX registers. Look at this. So both AX and BX will be a 16-bit register. The condition is both must be a register and both must be a same size. So if this is satisfied, then it is simply called as a register addressing mode. So if it is in cases, for example, source or destination, any one is a register means that is not called as register addressing modes. Look at this second addressing mode, immediate addressing modes. So immediate addressing modes is the 8-bit or 16-bit data is specified in the instruction itself. Look at an example, move DL, 08H. So this H is an hexadecimal, so the actual value is 08. So this 08 value will be moved to DL register. Here also the size should be same. See, look at this, DL is an 8-bit register, so automatically we are specifying a 8-bit values. We should not mention a higher values. So these 8-bit value will be moved to DL register. This immediate value must be present in source. This is not allowed in a destination. So destination must be a register or memories. So these value will be moved to this DL register. Look at this another example. Move AX, 0A9FH. So this H is a hexadecimal indication. We can skip it. Remaining actual values, look at this 0A9F. So this is the actual data. These 16-bit data that will be moved to AX register. So AX is a 16-bit register. Automatically the 16-bit value, that is 0A9F, will be moved to AX registers. So in this case, the value, whatever the value, that will be moved to AX register. So source can be a value. So if it is a source is a value, this is called immediate. So if the source also register, means it becomes a register addressing mode. And look at this. So actually here is a 0A9F. So we can take it. For example, instead of this, if we have an first letter also an alphabet, means we cannot use that. So for example, if we have an A, like that means, so we need to put its first digit as a 0. So it indicates the first value should be start with number, not an alphabet. Thank you.